हेलो स्टूडेंट्स, हाउ आर यू? हाउ यू आर फेयरिंग? अच्छा है, घर पे बैठे हैं पर पढ़ाई करते रहें। तो आपको पढ़ाने के लिए ही मैंने वीडियोस बना रहा हूँ। आज 9th स्टैंडर्ड का नंबर सिस्टम की पहली एक्सरसाइज करेंगे, दैट इज एक्सरसाइज 1.1। ओके, सो दिस इज एक्सरसाइज 1.1 NCERT। इससे पहले वाले वीडियो में मैंने आपको बताया था नंबर सिस्टम के बारे में। नंबर सिस्टम में आपको मैंने बताया था कि एक नंबर लाइन होती है और हर पॉइंट कॉरेस्पॉन्ड करता है किसी नंबर को, चाहे वो रैशनल हो इरेशनल हो, लेकिन एक ये फैक्ट है कि एवरी पॉइंट ऑन द नंबर लाइन कॉरेस्पॉन्ड्स टू अ रियल नंबर। ओके, नाउ पॉइंट की आप डेफिनेशन भी जानते हैं कि पॉइंट की डेफिनेशन के बारे में यह है कि इट हैज़ नो डायमेंशन। ये कोई भी स्पेस ऑक्यूपाई नहीं करता है, इट हैज़ नो डायमेंशंस एट ऑल। जब ये कोई स्पेस ऑक्यूपाई करता ही नहीं है तो कोई भी आपसे पूछेगा कि नंबर लाइन पे कितने पॉइंट्स आ सकते हैं, यू कैन से दैट infinite number of points lie on a straight line. Okay, so or howsoever close two numbers may be, they may be rationals, they may be irrationals, you can find infinite number of points in between two given points, howsoever close they may be. Okay, now just getting to the point, exercise 1.1 of NCERT में ये है, is 0 a rational number? Yes, it is a rational number. So remember, this is highly important, that 0 bracket ZERO, 0 is a rational number. क्यों है 0 rational number? क्योंकि इसको हम लोग P by Q के फॉर्म में लिख सकते हैं। For example, 0 can be written as 0 upon 11. This P and Q that are integers, and the denominator of course is 11, which is not equal to 0. So we can conclude that 0 is a rational number. Okay. Now, can you write in the form of P by integers? Oh yes, we can write it in the form of P by Q, and I have already made you understand. Now find 6 rational numbers between 3 and 4. Now we have to find out how many rationals? 6 rational numbers between 3 and 4. Okay, now because 3 is a rational number, 4 is also a rational number. I told you earlier also that we can find out infinite number of rationals as well as irrationals between any two numbers, howsoever close they may be. For example, 3 and 4, you have to find out 6 rational numbers. There are so many methods, and the easiest method is, you see, all these numbers here, of course they need to be in the rational form. They will be greater than 3 and less than 4. So we can write required rationals are, all these numbers need to start with 3. Say for example 3 point. So after this point, whatever you write, the total number itself will be greater than 3 and less than 4. Okay, so required rationals are, for example, 3.1, 3.2, you can say 3.002, 3.0000009. Of course they should all be terminating, so 3.3, 3.79, 3.8, etc., etc. Okay, just because they are all terminating decimals, so they are rationals. Of course, in case they ask you, say find out irrationals between 3 and 4, so that also I am telling you. Say here also you write 3 point, for example 1 0 1 0 1 000. This is not repeating. Okay, this is 10, this is 100, this is 1000, but of course this is a terminating decimal. But if you leave this as it is, then it will be a rational number. So better you put dots here. These dots tell you the nature of the numbers to come. So this is 110, 100, 1 so this is a decimal number which is non-terminating but non-recurring. So this is an irrational number. Similarly, 3.00235783. Randomly you choose the numbers, but don't forget to put this sign. Okay. So similarly, 3.00013000079, whatever it is, but they need to be followed with these dots. And there is what is called, they are coming randomly. They are not repeating, neither they are terminating. So these numbers are irrationals. Of course, they are asking for rationals only, but I have told you about irrationals also. So between 3 and 4. So simpler method, there is another method also. For example, what was the numbers? Say 3 and 4. So 3 and 4. So this 3 can be written as 300 upon 100, and this 4 can be written as 400 upon 100. Okay. So denominators, they are same, numerators are different. So you can write required rationals are, say, 301 by 100, 302 by 100, 303 by 100, 304 by 100, 305 by 100, and 306 by 100. So you can make out that these are all rationals. Why? Because they are in the form of P by Q. So they are rationals. Okay. So the choice is all yours. You can choose one of these two methods. Okay. Now let us get to the next question. That is question number 3. You have to find 5 rationals between 3 and 5. Sorry, 3 by 5. This is a rational number because P by Q form, and second is 4 by 5. Okay. Now there are many methods, but I will tell you the simplest method. Denominators are equal. So the number with lesser numerator is the lesser number. So of course 3 by 5 is less than 4 by 5. And between 3 and 4 there are so many numbers. So we can write like this: required rationals are, say, 3 and 4. You say 3.1 upon 5. Okay. 3.1 upon 5, 3.2 upon 5, and next is 3.3 upon 5. How many rationals? 5 rationals. 1, 2, 3, 3.4 by 5, and 3.5 upon 5. Okay. But you can't write them as answers because this is not in the form of P. Say 3.1. This is not an integer. So better you convert this into complete form of P by Q. That is 31 upon 50. Okay. So this will also be 32 by 50. But they are not in the simplest form. You just cancel them and write in the simplest form. That is 16 upon 25. This will be 33 by 50. This will be 34 by 50. They are not co-primes, so convert them into co-primes. That is 17 and 25. So this is 17 upon 25, and this is 35 by 50. Again you cancel that 10 and 7. So this is 7 upon 10. 1, 2, 3, 4, 5. So these are the rationals between the two given rationals. Okay. Now the last one is question number 4. You have to state whether they are true or false. Number 1. Every natural number is a whole number. Every natural number is definitely a whole number because the set of whole numbers, you can write like this, because the set of whole numbers consists of all natural numbers plus 0. So every natural number is a whole number. Okay. Next is every integer is a whole number. This is false statement, because there are other integers also which are not whole numbers. Of course, all whole numbers are integers, but all integers are not whole numbers. For example, -5. You can say -5. You can give an example, very good example. Say -5. -5 is an integer but not a whole number. Okay. Similarly, you can say that -98 is an integer but not a whole number. Now, the last one is every rational number is a whole number. Of course, this statement is also not true. That is false statement. Why? Because there are many rational numbers which are not whole numbers. Whole numbers is a set of, that is complete natural numbers, that is 1, 2, 3, and preceded by 0. That is 0, 1, 2, 3. That is the set of whole numbers. So rational numbers is a set of much more numbers. So you can say, you can give an example. For example, 1/3, which is in the form of p by q. Of course, all whole numbers are rational numbers, but for example, 1/3 or 2/3, they are in the form of p by q, and rationals also, but they are not whole numbers. So we have finished this exercise 1.1. I would ask you to do this exercise again and again, so that you can get into the into the details of these rationals and irrational numbers. And next chapter is irrational numbers, which I will start in my next video. So thank you very much. Lastly, I would request you to comment and share and subscribe and give us your feedback also to improve our quality. Thank you very much.